Okay, so in class today we had a couple of limits that we were working on. This one I happen to have made a mistake on. In part of number 5, we were trying to find the limit as x approaches 0 from the right of g of x. And notice that when we're approaching 0 from the right, we're supposed to use this rule for g of x. Hopefully you can hear me okay because that air conditioner is so loud. And yes, I feel guilty about complaining about the air conditioner because it keeps the room cool, but it is also loud. Anyway, back to our limit. So we're supposed to check what's happening as we approach 0 from the right. Since the values to the right of 0 are greater than 0, we're using this bottom rule. So as I've taught you many times, you're just supposed to try substitution first to see if it works. And so when I try substitution, I'm just going to plug 0 in where the x's are, and I get 2 times 0 minus 3 over 0 plus 1, which we all know is negative 3 over 1, better known as negative 3. So the value of this limit is absolutely negative 3. Just ignore that mumbo jumbo that I said in class today. I was confused. Okay, I'm going to smiley face that one. I'm feeling better about that. We got the pointy nose on that smiley face. Let's talk about this problem we had today in our groups that had the complex fraction. So one of the problems that you worked on today in your groups was this nasty limit here with a complex fraction. It might take me more than one slide to fill this in, so we'll see how this goes. But I want to talk you through your strategy here. Essentially what we need to do is we need to simplify this complex fraction. And the first thing I'm going to do is I'm going to try and subtract these two fractions. Once I do that, then I'll divide by the x minus 5. Okay, so what does it mean to subtract these two fractions? So I'm going to do this piece over here without the limit notation, and then we'll put it back together in the limit. I have 2 over x plus 3 minus 1 over 4. It just so happens that we were doing these addition and subtraction of rational expressions in Algebra 2b today, so I'm all studied up on this. But essentially we need a common denominator. So I'm going to multiply by 4 over here, and I'm going to multiply by x plus 3 over here. And I'll make a new fraction that is 12x plus 3 in the denominator, and in the numerator I'll have 8 minus x minus 3 when I distribute this negative 1. So that simplifies to 5 minus x. Now I can already see where this is going, so I am going to change this to negative x minus 5. When you pull the old switcheroo here, you just have to make it the opposite. So I'm just switching this bad boy around and then factoring out a negative 1. So it's negative x minus 5 over 12x plus 3. Okay, so back to my limit. That yellow stuff that I just did, I'm going to write in yellow, and everything else I'll write in green. We have the limit as x approaches 5 of the original x minus 5, which was on the bottom, and now we have this new yellow stuff, which is negative x minus 5 over 12x plus 3. Then we can rewrite this as limit as x approaches 5. The yellow stuff is in the numerator, which is negative x minus 5, that's a 5, over 12x minus 3. Or is that plus 3? It's plus 3. And I'm going to multiply by the reciprocal of this x minus 5, which is 1 over x minus 5. And this is great news because I can now cancel these out. That was the term that was giving me the business. Anyway, oh goodness. You know what I didn't do is I didn't do substitution first. Let's make sure you agree that when I plug a 5 in, I get 0 over 0. So in the numerator, it'll be 2 over 8 minus 1/4 divided by 5 minus 5, which is 0. So this is 0 over 0. So it is a smiley face. I do have to do the simplification. This is turning into a huge mess. Let me use a blue line. So all this yellow stuff here, that was just me simplifying the complex fraction. Okay, back to our problem. Oh, this video is going downhill quickly. The good news is, take a look at what we have down here. We'll keep it in green. We have the limit as x approaches 5 of negative 1 over 12x plus 3. And we can plug a 5 in now and simply get negative 1 over 63. And that is done. I'm going to put that in a green and white. I'm going to do a little Michigan State there with a white box, and I'm going to give a little smiley face for Sparty. Oh, goodness. Okay, so negative 1 over 63. The key here is, after you do substitution and find out it's an indeterminate form, you clean up the complex fraction, stuff cancels, you try substitution again, you get a real number, and you get the heck out of there. So that's the end of that problem. Keep up the good work. Don't panic. You can do these. Sometimes they're just nasty, and we stick to our algebra and see what happens. I'll talk to you soon. Take care.